Welcome back. We've been talking about properties of rational exponents and radicals. And now we're going to talk about simplifying radicals and rational exponents and this question of when do you stop? How do you know if you're done? When do you stop simplifying the problem and just let it go? So this question of when do you stop? We have a checklist. A radical is simplified when the index n is as small as possible. So we've looked at this example of the 8th root of x to the 6th, and we said that it wasn't simplified. We had to keep working with it because 6/8 is not a simplified fraction. It can become 3/4. So the 8th root of x to the 6th can be represented as the 4th root of x cubed. This is a smaller n. The index is smaller here, so this is considered simplified. It can't get any smaller than that, so it is fully simplified. The next one, the radicand contains no fractions other than 1 that are nth powers of an integer or a polynomial. An example is the 4th root of x to the 5th. X to the 5th contains the factor x to the 4th, which has a 4th root. So I need to rewrite x to the 5th as x to the 4th times x. This x to the 4th can come out as x times the 4th root of x. Another way of thinking about this is any exponents inside, or any factors and their exponents, must be smaller than the index. The next one, the radicand contains no fraction. An example of this is the cube root of 1/5. To simplify this, we're going to need to rationalize our denominator, which we'll talk about in the next video. And the last is no radicals appear in the denominator. An example is 1 divided by the 4th root of 3. This is a radical in the denominator, so it can't be there. This is again going to be simplified using or rationalizing our denominator, which we'll look at in our next video. If you've met all 4 of these criteria, your radical is simplified. If you have a rational exponent instead of a radical, it's considered to be simplified when it has no negative exponents. An example of negative exponents is x to the negative 1/5. This is not simplified because I have a negative exponent, so I would need to deal with that. It has no exponents that are not natural numbers in the denominator. Remember, natural numbers are positive integers. So that would be something like 1 divided by 3 to the 1/4. This is not a natural number, and it's in the denominator, so it's not acceptable. Other examples of non-natural numbers are negative numbers, so -3, -1/2. All of those would be invalid in the denominator. It is not a complex fraction. Now, complex fractions are fractions within fractions. So something like x to the 3 over 1/2 wouldn't work. Also, x to the 1/2 divided by 3 wouldn't work. If you have fractions within fractions, it's not good. And the last is the index of any remaining radical is the least number possible. So there we've got this x to the 6/8. This goes back to the same situation where 6/8 is not a simplified fraction, so we would want to write it as x to the 3/4. Something to keep in mind as we're working with radicals and rational exponents. These two problems represent the same thing. If this had been the problem I had been given, I would want my answer to be x to the 3/4. If the 8th root of x to the 6th had been the given problem, I would want my answer to be the 4th root of x cubed. In general, unless told otherwise, your answer should be in the form presented.